Good morning, afternoon, or evening. How y'all doing today? Welcome back to Moro's Math Corner. Today we're going to learn how to work with and solve compound inequalities. Consider the following two sets of numbers. Set A, which contains the elements 1, 2, 3, 4, and 5, and set B, which contains the elements 3, 4, 5, 6, and 7. The intersection of two sets A and B, denoted by A upside down U, that means intersection, B, so A upside down U, B is an intersection, is the set of elements that belong to both set A and set B. The word "and" implies an intersection or an overlap, if you will. It basically means that the intersection or the overlap of elements belong to both set A and B. Let's go ahead and list the intersection of the numbers that are in sets A and B. If you look at set A and B, the ones that overlap or intersect are 3, 4, and 5. So the intersection of sets A and B would be denoted by the set that equals 3, 4, and 5. Because once again, those are the elements in both sets that are shared or intersect or overlap. If we look at the union of sets A and B, denoted by A regular U, which stands for union B, is the set of all elements that are in sets A and B. So again, it's a set of all elements. We're looking for a combination or a union. The word "or" implies a union or everything combined together. If we go ahead and list the union of numbers that are in sets A and B, we look at our sets A and B again, and we're going to combine them. It's going to be everything together. So the union of sets A and B would be the following set: 1, 2, 3, 4, 5, 6, and 7. It's all the elements together. It's a union of everything together. We do not have to rewrite repeating elements. As you notice, we did not rewrite 3, 4, and 5. So again, an intersection is where you have an overlap, and it is denoted by the word "and." A union is when you get all of the elements and combine them together, and it is represented with the word "or." Compound inequalities consist of two distinct inequalities joined by the word "and" or the word "or." The graph of a compound inequality with the word "and" contains the overlap or intersection of the graphs of the two inequalities that form the compound inequality. Let's go ahead and see how this works. Let's go ahead and graph x is greater than or equal to 3. So we have here a bracket on 3, and we're going to the right forever. And then let's go ahead and graph x is less than or equal to 7. We'll use a different color. So we've got a bracket on 7, and that goes on forever as well. To the left, because it's less than. Now, let's look at the combination of x is greater than or equal to 3 and x is less than or equal to 7. If we think about it, we're going to go ahead and put one graph on top of the other. And we're going to see here that there is an overlap right here in purple in the middle. Both the red and the blue overlap here, right in the middle. So x is greater than or equal to 3 and x is less than or equal to 7 the intersection of that would be between 3 and 7, because that's where the graphs overlap. That's where they have an intersection. You can rewrite the above compound inequality involving and as a single inequality in set builder or in interval notation. When we're dealing with set builder, we write it as such. Please note that the x is in the middle. So x is greater than or equal to 3 and x is less than or equal to 7. But in interval notation, if you remember, the graph simply shows you the interval notation in a very easy form. So it would be bracket 3 to 7. Please remember that in interval notation, we go from smallest value to largest value. And once again, this is read as x is greater than or equal to 3 and less than or equal to 7. Now, the graph of a compound inequality with the word or contains the union of each graph of the two inequalities that form the compound inequality. Once again, let's investigate these graphs individually. Let's go ahead and graph x is less than or equal to negative 2. So we've got x is less than or equal to negative 2. We've got a bracket, and we're shading less than to the left. And then let's go ahead and graph x is greater than or equal to 1. So we've got a bracket on 1, and we're shading to the right. Now, let's go ahead and investigate what x is less than or equal to negative 2 or x is greater than or equal to 1 looks like. When we combine both of these together, if you notice, there's no overlap here. There is just simply two different graphs that we are going to go ahead and make a union of. So when we go ahead and graph the union of both of these, it's both the union of x is less than or equal to negative 2 or x is greater than or equal to 1. You can write the above compound inequality involving or as a single inequality in set builder and or once again in interval notation. In set builder, once again, please note that the x is in the middle and we've got x is less than or equal to negative 1 or greater than or equal to 1. And I'm sorry, that's x is less than or equal to negative 2 or x is greater than or equal to 1. In interval notation, once again, please remember that the graph lets you know exactly what the interval notation looks like. And we've got from negative infinity to negative 2 in bracket in union with 1 in bracket to positive infinity. Please remember that infinities always have a parentheses in interval notation, and when it's greater than or equal to or less than or equal to, they have brackets. Now it is read as x is less than or equal to negative 2 or greater than or equal to 1. Now this is not the usual way to write or inequalities though. They are usually written as x is less than or equal to negative 2 or x is greater than or equal to 1. They usually separate it with the word or. That does not happen all the time with the and, but it usually happens with the ors. Okay. What compound inequality represents the phrase in set builder and interval notation? And let's graph the solutions. All real numbers that are greater than negative 2 and less than 6. Well, if we look at this here, okay, we make our graph. We've got 0, we've got negative 2, and we've got positive 6. I'm going to use a color code here to help this come to life. All real numbers that are greater than negative 2, so we've got here in blue, greater than negative 2, so that's going this way forever to the right, and less than 6. So we've got, again, a parenthesis, but we're less than 6. If you notice, Where do the blue and red solutions overlap? You got it, right in between. And that is the graph, or the solution rather, of this compound inequality. So the solutions would be x is greater than -2 and less than 6. In interval notation, they would be denoted as parentheses -2 to 6. Once again, look at that highlighted area of intersection. Where they intersect or overlap, those are the solutions. Let's look at an OR one. All real numbers that are less than 0 or greater than or equal to 5. Let's go ahead and graph a line here. We've got our 0 and we've got our 5. Let's color code once again. All real numbers that are less than 0, so we've got a parentheses and we're going to the left because it's less than, or greater than or equal to 5. So we've got bracket and we're shading to the right. Since this is an OR, it's a union of all the solutions. So the union of all these solutions would be written as such. X is greater than 0, X is less than 0, or X is greater than or equal to 5. In interval notation, which is much more sophisticated, we're talking about the solutions are from -infinity to 0 in union with bracket 5 to +infinity. All right, awesome. Now, let's go ahead and learn how to solve this. Solve and graph the given compound inequality. Write the solutions in both set builder and interval notation. When we're dealing with a compound inequality that has no words, we're usually dealing with what's called an AND. And in order to solve this, we want to get isolate the variable. We want to get the variable all by itself. So we've done this before. So we're going to go ahead and add 4, but we got to add 4 since it's a compound inequality to both sides. It's going to leave me with a 2. We got a 3y over here, and this is 18. I'm going to divide 3 again to both sides. And y would be greater than 2/3 and less than 6. When there are no words, and is the implied word here. So let's go ahead and now graph it. So we've got our set builder right here. Now let's graph it to make our interval notation a little bit easier. So we've got 2/3 over here. We've got our 6 over here. I'll color code it once again. Y is greater than 2/3. So we're going to the right here in purple. And it's also less than 6. So we've got blue here, and we're going to the left. And where do we have the solution? Where these purple and blue solutions intersect. So the interval notation solution would be between 2/3 and 6. It's that easy. Okay, number 3. Solve and graph the given compound inequality. Write the solutions in both set builder and interval notation. When you have the word or, it's self-explanatory, it's going to be an or. You're going to combine all the solutions because or means union. So let's solve one at a time. You can split it down the middle. So we're going to subtract 2 to both sides. We've got 3x is less than -9. Divide by 3. So we've got that x is less than -3. Or, on the other side, we're going to subtract 5 to both sides. -4x is less than or equal to -4. We're dividing by a -4, so please remember that whenever you divide by a negative, you've got to flip the inequality. So this becomes now x is greater than or equal to 1. And you've just solved for your set builder. Now let's go ahead and graph these to make the interval notation a lot easier. We have our 0, we have our -3, we have our 1, and x is less than -3, so parentheses, and we shade to the left because it's less than. And then on the other side, we have x is greater than or equal to 1, so that's a bracket, and we're shading to the right. So my interval notation would be from -infinity to -3 in union with bracket 1 to +infinity. And there you have it. Now let's take a look at a word problem, because word problems are part of life and part of a lot of the tests you're going to take. So let's not be afraid of them, and let's learn them. To earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. Inclusive means that 84 works and 86 works as well. So everything in between 84 and 86 and including 84 and 86 percentage. You scored an 86, 85, and an 80 on the first 3 tests of the grading period. What possible scores can you earn on the 4th and final test to earn a B in this course? So you know that you want the average to be between 84 and 86. So that means that the values have to be greater than 84 or less than or equal, greater than or equal to 84 and less than or equal to 86. And so far you have an 86 plus an 85 plus an 80 plus your 4th and final test grade of X, because we don't know what that is. If you remember what an average is the sum divided by the total number of values. So I've got 1, 2, 3, 4 values here, even though my 4th value is unknown. So I'm going to divide that sum by 4. And now let's go ahead and solve. If you remember, you can get rid of any denominator, whether it's a number, variable, or polynomial, by multiplying the LCD, or that singular denominator, to everything on both sides. So I'm going to multiply 4 to the 84, to this set, and to the 86. So 4 times 84 will render me 336 with a less than or equal to symbol. 4 times 86 plus 85 plus 80 plus x divided by 4, the 4 will cancel, leaving me with the sum of 86 plus 85 plus 80 plus x, which would be 251 plus x, and less than or equal to 4 times 86 would be 344. Now I want to solve for x, so I want to isolate x, so I'm going to subtract 251 to both sides. And 336 minus that 251 gives me an 85. We have the less than or equal to symbol. The 251s cancel. We've got x. We've got a less than or equal to symbol. And 344 minus 251 will give me a 93. Sorry about that. A 93. So in order for you to achieve the average of a B, which is between 84 and 86 inclusive, you need to earn greater than or equal to an 85 or less than or equal to a 93 on the 4th and final test. And there you have it. Let's just do one more, but let's go ahead and add some fractions, because sometimes we are afraid of fractions and then there's nothing to be afraid of. Let's solve and graph the given compound inequality. Write the solutions in both set builder and interval notation. Please remember that when we're dealing with distributive properties and equations, we want to go ahead and first distribute everything that's being multiplied to that polynomial. So we're going to have 3/4 x here plus 3/4 times 4 is 3, and that is less than or equal to 1. I'm going to go ahead and subtract 3 to both sides, giving me 3/4 x is less than or equal to -2. Please remember that the 3/4 is being multiplied to x, so we're going to go ahead and divide 3/4 to both sides. And please remember that when you divide fractions, you stay, change, flip. So x will be less than or equal to -2, stay, times change, flip 4/3. So x will be less than or equal to -8/3. Or, on the other side here, we have 3/2 x plus 3/2 is greater than or equal to 15. If you don't feel like working with the denominators, please remember that you can simply go ahead and multiply every single term by the LCD, which in this case is 2. So 2 times 3/2 will give me 3x, plus 2 times 3/2 will give me 3. And that's going to be greater than or equal to 2 times 15, which is 30. We're going to subtract 3 to both sides. 3x is greater than or equal to 27. Divide by 3. And x is greater than or equal to 9. So we have our set builder. Let's go ahead and graph it now. We have a -1. We have a -2, and we have our -3, and -8/3 is -2 2/3. So we'll call it right here -8/3. And that's going to be less than or equal to, so bracket and shaded to the left. Or x is greater than or equal to 9. We'll plot our 9 over here, and that's greater than or equal to, so that's bracket and shaded to the right. And now from the graph, you make the interval notation come to life. So my final answer would be from -infinity to -8/3, bracket in union with bracket 9 to +infinity. And there you have it. Those are compound inequalities. Thank you for watching. Hope you learned a lot, and come back anytime. Take care now. Bye-bye.